Here comes some sample problems just to check your understanding. What is the reference angle for 210? Let's start right there. So we take our spinner, we spin it up because there's an invisible plus 180 plus 30, and we stop. Now that has to be my reference angle, so that would be 30 degrees. What quadrant is it in? Third quadrant. I just throw that in for free. What about negative 285? Well, that starts here. You got to go down. So look at that's 90 plus 90 plus 90 is a total of 270 in the negative direction. I have to go another 15 in that direction, and my reference angle is right here. It's not here, it's right here. It's between my x-axis and my spinner. So that's 15. So what would this be? It'd be 75 degrees. That's my reference angle. You know, maybe we want to make it alpha, but no big deal. Negative 45. So there it is. That means I got to go down 45. My reference angle has to be right here. Well, if this is down 45, my reference angle, this could be tricky for some of you, but it's a positive 45. Again, the negative just means down. It doesn't mean it's a negative angle. It's a positive angle going down. So I hope that doesn't confuse you. Now they're going to ask you the same question in reverse. They're going to give you the reference angle as 10 degrees in the fourth quadrant. So you're like, okay, let's draw a picture. There it is. Now that might be too much, but I got to fit it in. There's 10 degrees. So it asks you, what's the angle? So it's really asking you, how far did you have to spin your spinner to get there? Student number one, who's locked in positive world, they're going to start here. They're going to go all the way around and go, aha, that's 350. You're not wrong. What about negative? That'd be just negative 10. So either one's correct. Just depends on what they ask for. Maybe they'll ask you for one positive, one negative. Interesting problem here. It says angle theta has measured 60 degrees. So they're telling you, because they've been using theta as the spinner, so they're saying, all right, spin it 60 degrees. So you're like, okay, let's go. There's my spinner. There's an invisible plus there, so you hit it up, and that would stop right about there. Now, your accuracy is very important in this section. You're going to see why. Now, do I create my right triangle by going this way? Never. Never. Now, what they're saying is the side intercepts a circle at xy. Now, I got ahead of myself. So what they're saying is there's a circle like this, and you're supposed to find that point, x, y. Well, how are you going to do that? Well, I got ahead of myself because I could see where this problem was going. I need to build a triangle. Do I go back to the y? No. Back to the x? Yes. So there's my 60, there's my 90, there's my 30. Now this always throws students when they don't give you like solid evidence. But we're going to get in the habit. When they don't give us like dimensions for a 30, 60, 90, make your life easy on yourself. Let's call this guy 1. Now, something I didn't say, I tried to say it at the end of the pre-lesson, your hypotenuse is always, 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 always positive. Because it's a spinner. It's always going to have length. It's like a pendulum sort of thing. It will never have a negative distance. So this is 1. This is 2. In this case, because you double your shorty, but then what I'm interested in is this, because this is my y value. I got to multiply that by the square root of 3. So here's my x, here's my y. So the point would be 1 comma square root of 3. In other words, x is 1, y is the square root of 3. Now what if they threw an additional thing at you, and they said the reference angle, which they seem to use alpha, is 60 degrees and it's in the third quadrant. What would the end of the spinner be? So that's like, okay, my reference angle is 60 degrees in the third quadrant. my spinner had to stop right about here. So there's the point, X, Y, and you gotta find it. Well, you're gonna create your triangle. Remember, my reference angle was 60, making that 90, making that 30, but remember, we're in the third quadrant, which means our X has to be negative, our Y has to be negative, because it's left and down. So we go, okay, well, forget about the negatives. I know this is a 1, I know that's a 2, the side opposite to 60 has to be the square root of 3. But, now I gotta put the negatives in. Remember, my hypotenuse is always positive. What's this point? Supposed to be -1, negative square root of 3. That's a different way of saying X is -1, Y is negative square root of 3. Okay. There's one more problem I gotta show you. Last problem in your sample problems. If the reference angle is 13 degrees in quadrant 3, all right, we better get that drawing drawn. Quadrant 1, 2, 3, it's right here. 13-degree reference angle is going to be a little shaver right there. They're asking you, what's the angle's measure? In other words, if I start in standard position, my initial side, how far do I have to spin my spinner to get there? Now, they don't tell us positive or negative, so I'm just going to assume they want the positive. Well, that would be 180 plus that little shaver, plus 13. That's 193 degrees. Now, what if they changed it from quadrant 3 to quadrant 2? Well, my quadrant 2 is actually right here. 13-degree reference angle would be this little shaver right there. So how far do I have to spin my spinner to get there? I mean, there's a couple ways of looking at it. I could say 180 minus 13, which is 167. Or, if you're a piece-by-piece person, from here to here is 90, and from here to here would be 90 minus 17, which would be 77. And then I'd add 90 plus 77, I'd still get 167. So, different ways to do it. You are ready for your homework. Go get it.